Well, everybody's set. Great. Hello and welcome to my presentation. This is going to be about browser hijacking via cross-site scripting. So first of all, let me introduce myself shortly. My name is Daniel Fabian. I work for Seconsult Unternehmensberatung GmbH here in Vienna, and I do mostly penetration testing and also some consulting stuff like ISO 27000 and so. But my heart is actually in penetration testing. I like it better to sit in front of a computer hacking instead of presenting before management. Actually, this is kind of a large audience for me, so please bear with me if I'm a little bit nervous. Just a couple of details about my company. We were founded in 2002 in Austria. We have branch offices here in Vienna, and we were founded in Wiener Neustadt, where we still have an office. And some years ago, we also opened up a branch office in Montreal, Canada. And starting next year, we'll also be in Germany. Well, we are focused completely on information security. We don't sell any software or hardware which makes us independent from vendors. So whenever we find security flaw in a product, we don't have to fear that the vendor is going to be a problem for us. We're completely independent. We're specialized in security audits, especially with web applications and basically all kinds of other services. And security coaching, a big step for us was we developed the ONR 17700, which is an Austrian standard or some kind of standard. We developed it together with the Austrian Standards Institute, and it's about web application security. It states the minimum requirements for making a web application secure, the requirements the application needs to fulfill in order to be secure from SQL injection, cross-site scripting, and file inclusion, whatever. It is also certifiable, so if you have a web application, you want to make sure it is secure, you can certify it according to this standard. This requires a source code audit, so after the audit you can be pretty sure that most flaws have been found. We can't name most of our clients because we respect their right to refuse to let us take them as reference in order to protect them from hackers like you, so not to attract them. Some customers we may name are, for example, the European Central Bank, Austrian National Bank, Mondi Packages, Austrian Lotteries, or OMV here in Austria. All right, so what can you expect from this presentation? Basically, it's all going to be about cross-site scripting. Cross-site scripting has been around for a while, actually like a decade or something like that. But I surfed the full disclosure archive a couple of days ago, and there's still practically every day or almost every day some cross-site scripting posted. For example, I found one that was published about the site of the Bank of America, where you should expect some security. But you just need to take the parameter MSG, add some JavaScript, and it's going to be executed. Another cross-site scripting is someone found and published on full disclosure is, for example, in How to Forge. And I don't know if any banking folks are present that know Fish Market. It's a page that has specialized in finding cross-site scripting in other web pages. They published for basically every major bank in Austria and Germany cross-site scripting vulnerabilities. It's a little bit old, the page, but it hasn't been updated for a while, but there's still vulnerabilities open and have been found in mid-2006, and the affected companies still haven't been able to fix the vulnerability. All right, so some of you may probably think cross-site scripting, well, actually, this is boring. Everybody hates it when someone posts it, cross-site scripting flaws on mailing lists like Full Disclosure or Bugtrack or whatever. I found one particularly interesting posting, which is not so old, posted by Repex on November 11th. It's called On Cross-Site Scripting and Its Technical Merits. Basically, it's an article questioning if cross-site scripting has a place on mailing lists like Full Disclosure or Bugtrack. The reasoning behind the article is cross-site scripting isn't technical, no matter how it's used, according to the author. People who use cross-site scripting on pen tests, real hacking, anything but phishing are lame and can't write real exploits, where real exploits are defined as non-web or other web bugs like SQL injection and stuff. And well, publishing cross-site scripting shows your weakness. Well, while I agree on the last part, publishing cross-site scripting shows your weakness, because I think you should at least give the webmaster of the affected page the chance to remove the cross-site scripting vulnerability before publishing it. I think cross-site scripting indeed still has a place on mailing lists like Full Disclosure. It cannot be as easily exploited as other web bugs like, for example, SQL injection. The thing is that with SQL injection, you are actually attacking the server. And the server is always there. It will always give you your response. So when you find an SQL injection vulnerability, you type in your SQL statement, and basically immediately you get the response from the server. You get the content of the database, you get the usernames and passwords, whatever the vulnerability is about. With cross-site scripting, it's not quite as simple. Cross-site scripting requires at least some kind of user interaction because you don't attack the server itself. Even though the vulnerability is on the server, you are attacking, in fact, the clients. The clients need to visit the page, for example, where your JavaScript is loaded, or they need to click on a link. So the results from this vulnerability isn't as instant as with other web bugs, which is why I think that some people think of cross-site scripting as boring, because they need to do more work. They need to send out phishing mails, for example, in most cases anyway, or they need to place some JavaScript statically on a page. Some fun cross-site scripting that I'm not sure anyone has ever tried. I didn't, but I just made the scan for this presentation. You just fill out a transfer sheet and wire some money to some of your friends or not so much friends, whatever. And as note to the payee, you include some JavaScript. What happens when you file this sheet is probably someone is going to enter the text that is on the note to the payee, which is, in our case, some JavaScript, which is loaded from a server, which is located somewhere in Florida. And the cross-site scripting is loaded and does some bad stuff to your online banking when the user logs into his online banking account and has a look at the transactions and the money he got. You want to know why I know that this server is located in Florida? Well, actually we hacked this server. And I don't think the guy that owns the server minds, because he was already arrested by Lieutenant Kane from CSI Miami, as this screenshot shows. All right, so seriously though, what is cross-site scripting about anyway? Basically, there's two different kinds of cross-site scripting. One cool cross-site scripting and one not so cool cross-site scripting. It's permanent cross-site scripting. This is the cool kind because you can store JavaScript on the server. You inject some scripting code. It's mostly JavaScript, but it can actually be anything. It can be objects like Flash, applets, or just plain HTML, whatever, into the web application. The application stores the JavaScript, and whenever a user surfs on the page, the JavaScript is loaded. This is mostly found in applications like forums, for example, or webmail applications, or file uploads. A fun example is, for example, did you ever see one of those online recruitment portals where people can apply online, and mostly there is also a possibility to upload files like your CV and whatever. Sometimes they just allow PDF, but sometimes also pages like HTML are allowed, so you can upload your CV in HTML. Well, what happens when someone uploads an HTML file with some JavaScript is probably sometime after you file your application, someone from the HR department is going to have a look at your application, load the files that you have been uploading, and the JavaScript is executed, which is actually pretty comfortable because then you even have the user account of an administrator, can steal the cookie and get access to their backend. The second type of cross-site scripting is temporary cross-site scripting. This is where the scripting code is injected on the fly, and it requires way more user interaction than the permanent cross-site scripting type. The reason is that mostly you use the HTTP GET parameter to inject JavaScript, but it can be basically anything. It can be cookies, headers, post parameters, whatever you are able to manipulate on the response from the server. So in this case, as already mentioned, user interaction is required. I made the example at the beginning of the presentation with the Bank of America cross-site scripting. This is a typical temporary cross-site scripting because the message tag needs to be used to inject the JavaScript. So in order to largely exploit such a cross-site scripting, you need to craft, for example, phishing mails and send them out to millions of users and hope that some users will be stupid enough to click on your link and the JavaScript is executed. Another way is, for example, just posting your link to a forum, and when someone hits the link, the JavaScript is also executed. So with cross-site scripting, you can have some fun. I collected a couple of ways or fun things to do with JavaScript. One of my favorites is always webmail, because webmail has the advantage that most webmail clients or servers, whatever you call them, display HTML mails. And the problem is that normally you have no problem in filtering JavaScript when you don't need to display HTML. But as you require HTML and need to show HTML tags and so on, it is pretty hard to get out all the JavaScript, because JavaScript, there are so many ways to inject JavaScript through an HTML page. For example, it can be in the event handler, like on click, on error. It can even be in cascading style sheet files. You can do all sorts of tricks in order to make the script tag obfuscated. For example, with Internet Explorer 6, there was a vulnerability where you could make the what's it called in English? Bitte Klammer auf.
Angel bracket.
Okay, yeah, that bracket, and then a null byte, and then script. The browser still recognized it as script tags, but most of the application that filtered out script tags didn't recognize it anymore. So that was a trick that worked a long time with webmail applications. Once you have found a cross-site scripting vulnerability in webmail, all you have to do is send an email to a user that uses the webmail and wait until he opens his mail. When he opens his mail, the JavaScript is executed in his browser, and you can do the classic, namely steal the document.cookie. As in the cookies, mostly the session IDs are stored. You can have his session ID, and at least while the session is open, you can take over his session and read all his emails. The second method was already mentioned at the beginning of the presentation, which is via online banking. Another fun way is to, for example, use exactly the sheet or wire some money via online banking. And when the user logs in next time, the JavaScript gets active and stays active in the background. We'll see later on how this can work, for example. And when the user does his next payment, you just in the background change the amount and the destination account of his wire, and instead of paying his electricity bill, for example, he pays you an arbitrary amount. Cross-site scripting has another advantage, as it is executed on the client and not on the server, you can basically do anything the client does, which is, for example, surf on the internet. There is a nice way, which was actually only recently found, called anti-DNS pinning, to get to the victim's intranet pages and surf on the internet from remote. How this works is that most browsers have a way of preventing or enforcing the same origin policy by a method called DNS pinning. DNS pinning means that whenever a domain is resolved to its IP address, the IP address remains in the cache of the browser, and even though the domain has a short time to live and the IP address for the domain is updated, the browser still uses the old IP address in order to enforce the same origin policy. There's one small trick that enables the attacker, however, to circumvent this DNS pinning, and it's called anti-DNS pinning, surprisingly, which works like this. First, the user requests a page from www.attacker.com or whatever, which can be also a page that has been taken over by an attacker, any compromised website, any web page from a company that wants to harm his customers, whatever. The DNS server returns the IP address for this domain, and the browser makes a request to the IP address and loads the page. The page does nothing else but request itself again a couple of seconds later. In the meantime, however, the DNS server changes the IP address for the domain. For example, to something local like 197.168.1.1. Let's just say the internet is located there. So when the page reloads itself, for example via JavaScript, the browser, due to DNS pinning, requests the old IP address. However, the attacker in the meantime closed the HTTP port on the old IP address, which can be, for example, done via dynamically created IP tables rules, so that exactly one IP address isn't allowed to get on the HTTP port anymore. And when the browser can't reach the HTTP port of the old IP address, he's going to refresh the IP address. The refreshed IP address is now the local IP address from the intranet. The browser requests www.attacker.com, thinks it's still the old site within the internet somewhere, but in reality it is located on the intranet. Using JavaScript or cross-site scripting, the attacker can now read the content of the intranet and send it via JavaScript to his server and have a look at all the intranet pages that are located at the client side. So yeah, this can be exploited, as I said. Just place the according scripts on any arbitrary server, and anyone who surfaces this web page has his intranet read if the attacker knows the IP address of the intranet. You can also port scan the intranet using cross-site scripting or JavaScript simply by loading images from various ports of internal IP addresses. Via JavaScript, the attacker has to measure the time how long it took the browser to issue an error message. If it takes very long, he knows the port has been is closed. If there is a fast error, the attacker knows either it is an HTTP port and the image didn't exist there, or alternatively the port is open but it's not an HTTP server, then the error message also comes pretty fast. There's actually quite a difference, a number of seconds, so it's pretty easy to tell if a port is open or closed. Another classic is the cross-site scripting phishing. If anyone finds a cross-site scripting vulnerability on a banking site, JavaScript can be used via, for example, document.write to exchange large parts of the site. One trick, for example, is to simply change the action tag of the login form or the action parameter of the login form. So when a user enters his account number and his PIN to log into his online banking account. Instead of sending it to the banking server, it is sent to a server from the attacker, and this doesn't even require to take over some sessions or something like that, but instead the real account number and the PIN in clear text is sent to the attacker. One way that we are going to talk about now a little bit longer is remotely controlling the victim's browser. We had the idea that it would be great to make a JavaScript malware, something like a Trojan horse, which is implemented in JavaScript and which infects the user whenever he surfaces a page where the JavaScript is loaded. All the information that the user does during his session in the browser should be logged and sent to the server. So using such a malware, it would be possible to, for example, log the key presses that were done in the window, steal all the cookies, and even have a look at the pages the victim is surfing on. This is possible because the power of JavaScript. JavaScript has a lot of features that can be exploited for such an attack by any attacker. For example, there's event handlers. You all know in your HTML, you always have these on click, on key press, on error, on whatever, on load. There's lots of event handlers, and you can all catch them. So whenever, for example, someone makes a click somewhere in the window, this can be recorded via JavaScript. And then in turn sent back to the server in order to follow the user. It is also possible to remotely control the browser. There's nothing more simple than just setting the location of the browser to any arbitrary page. So whenever a user is infected by this malware, you can just send him to any location he wants. And as the JavaScript is loaded on the page the victim visits, the same origin policy is completely circumvented. This makes it on the one hand possible to access the cookies because JavaScript can only access cookies from the domain where the JavaScript is loaded from, and on the other hand, via history.back, the attacker can even read the browser history, at least of the domain from where the JavaScript was loaded. Okay, so when we had this idea to write some JavaScript malware, at first we did some requirements engineering. What should such a malware be able to do? The first thing is the most important, but as we're going to see, not quite so simple requirement is that once a victim visits a web page that contains the JavaScript, the web browser should become infected. And at least during the session while the user browses in this single window without changing the address bar, the malware shall remain active. Another requirement, which is basically clear but is not so simple sometimes, is that the JavaScript that is used should be cross-browser compatible. Actually, JavaScript should be standardized, but it isn't. There's a lot of exceptions. There's some bugs in some browsers that need to be circumvented. So this was one of the requirements that was pretty hard to find out what browser requires what special treatment. A very easy requirement is that all cookies that are set on the victim should be sent to the attacker. This is the classical document.cookie exploit, usually done via cross-site scripting. A little bit more complicated and also a little bit more fun is key presses should be intercepted and locked. So whenever the user enters his username and his password, all the keys are pressed, or whenever a key is pressed, an event handler is called, and this event handler should lock all the keys and send them again to the attacker, which makes it actually useless to steal the cookies, because if you have the username and the password, you don't need the cookies any longer because the cookies are or the session ID is restricted to a session, and using the username and password you can log in whenever you want. All right, now a rather hard requirement also was that the malware should be able to work across links on the same domain, which is clear. This is a very important requirement, because otherwise the malware would be just active on the first page, and whenever the user clicks another link, the malware wouldn't be active again. So it was clear that it is required that while the user surfs on one domain, the malware needs to remain active. Another hard requirement was that the malware should be able to work across domains. So even when the user leaves his current domain, for example, he's surfing on www.decker.com, and he goes to another page, say Microsoft.com, the malware should remain in the background and still keep sending all the information to the attacker. Of course, we want to do remote shoulder surfing. That means that, shoulder surfing, someone is surfing his browser and you're looking above his shoulder what he's looking at, perhaps reading his emails and something like that. You should be able to do this with JavaScript malware too, but not only a couple of centimeters behind him, but rather a couple of 100 kilometers away via cross-site scripting or JavaScript. And finally, it should be possible to remotely control infected browsers. All right, so now let's come to the implementation. We actually implemented an alpha version of this JavaScript malware. I'm going to show you something of it at the end of the presentation. But let's just first have a look how we did it, what problems we had to implement such a system. Well, as I already said, to get the victim infected is not as easy as it sounds. The beginning is pretty simple. You need to load some JavaScript. For example, we placed a JavaScript, xt.js, on a server, and all you need to inject into the client are these short tags. And this makes the victim load the JavaScript and become infected. Now, the problem is that we want to have it client-server based, so that the server is able to send commands to the client. Problem is, this is not the way the HTTP protocol works, because normally only the client can initiate connections to the server. It's not possible for an HTTP server to request something from a client. So the solution is actually pretty simple, and I think the only one that is possible, namely polling. Every couple of seconds, the victim pulls JavaScript from the client, and if there is something for the client to do, the server changes the JavaScript that is pulled from the server, and the client does whatever the server tells him. Commands that can be executed might be, for example, execute some JavaScript on the client, tell the client to display an alert box showing you have been owned or whatever. Get me my cookies, get me my key presses, or I want to see what you're currently looking at. In order to handle multiple clients, of course it should be possible. You want to infect not only one client and control him, but you want to infect quite a number of clients. Basically, this can be anything and is dependent on how much traffic there is on the web page that has been compromised via cross-site scripting. It is required to have a unique ID in order to identify the clients. Okay, the next requirement, all cookies sent to the client while infected should be intercepted. This is basically a very easy one. Next time the client pulls from the server, just tell the client to send top get outer window document cookie to the sender. Get outer window is actually a custom function we implemented. It does nothing else but go through all the frames. There may be stacked frames, and in order to get the cookies from the top window, so to say, we just use this function. And then send the cookies to the server so that he can have a look at it. A little bit more tricky is, as I already mentioned, logging the key presses. In theory, we would have to put on key press handlers on anything, on form tags and whatever. But luckily, there's a great feature in HTML, namely on key press can be added to the body tag. And then whenever within the window someone presses a key, the key press is locked simply with one usage of the event handler. So we get the content of the HTML via window document body path node inner HTML, and via regular expression we replace the body tag, or better, we just add an event handler on key press is keyff event, where event is just a variable where various information about the event is stored. A mini keyff is just a mini JavaScript keylogger. This is one of the examples we had to overcome with browser incompatibility. Internet Explorer, for example, has another member of the event object that stores the key code. With Internet Explorer, it is event.keycode. With any other browser, it's e.wish. Alright, then we just reverse the character by getting the character from the jar code and append to a global variable. We just call document all keys the character that has been pressed. Getting the key information is exactly the same as with cookies. Next time the client polls, we just have him return all keys to the server. Now, finally, there's a little bit more interesting requirement, because it's a little bit harder, namely that the malware should be able to work across links on the same page. The solution is, again, not so difficult. We can use XML HTTP requests. It's great. One of the few great things about Ajax is that we are now able to do arbitrary HTTP requests via JavaScript. Just like with window, with on key press, we add another event handler to the body tag, namely on click. And whenever a click takes place in the window, it is caught by the clickff event. What comes in handy is additionally that there is some call it vulnerability, I wouldn't call it that, but when someone points his mouse pointer over a link, the href attribute from the link tag is shown in the status bar. It is not shown what is in the on-click. So when you point a mouse over a link, you think to see what kind of page is loaded in the status bar, but via on-click you can just point the browser to basically anything via JavaScript. This was a big thing in 2004. Microsoft even advised to better type in URLs instead of clicking on them. What happens now when a mouse button is pressed? The simple case is a normal link was pressed. In this case, just use JavaScript to gauge the href attribute and the target attribute. We want to be compatible with frames. So even if it's a frame, a page that uses frames, we want to show the page in the correct target, and perform a simple XML HTTP GET request, and put the output of the request, so the response, to body parent node inner HTML of the right target. This has two implications. The first one being that the URL in the browser bar will not change while you are infected. It will look to the client as if the browser always is on the same domain, because just the content of the body tag is exchanged depending on what page you're currently on. This makes another problem, namely that relative path may be wrong. So if you go to another subdirectory, The images that are loaded via relative path, for example, won't be able to load anymore, but there's a simple solution to this, namely the base tag. And via the href attribute, you can just give him the new relative path from where to load all the images, which makes it easy because now the browser is handling the relative links and we don't need to do that anymore. The complex case is if a form button was pressed. We also want to be able for the malware to stay alive even though a form was submitted. Luckily, we already have our on-click handler. So the event object tells us in which form the submit button was pressed. Now we need to loop through all the elements of the form because our on-click event handler prevented the form from actually submitting. So unfortunately we can't use xform.elements because for some reasons, some strange reasons, it doesn't contain all form elements, but rather we have to manually get all input elements, all text areas, and all select boxes, for example with checkboxes or radio buttons. Alright, then we just do the XML HTTP request and again setting the inner HTML to whatever the request returned. Okay, this is possible when the user clicks on a link that shows to the same domain. But due to the same origin policy, which is basically a good thing, XML HTTP requests won't allow requests to alien domains or other domains. The solution to this is that the server, of course, can request anything it wants. So therefore, whenever the infected client leaves the current domain, we just send the server a message that he needs to request a page for us. For example, post type. Here we pass in the URL, the URL, and the browser, the server takes care of requesting the page and returning the input. And again, the inner HTML is just set to send to the client for display. Finally, we want to do remote shoulder surfing. That's again a very easy one. All we need to do is to continuously send the top document body path parent node inner HTML to the server, and the server just can display it within an iframe. Okay, and the final requirement was to remotely control infected browsers. Actually, I would have loved to show you this live, but unfortunately my VMware let me down today in the morning. So I quickly made a couple of screenshots. I know it's not the same as a live performance, but I'm sure you will see what the system we implemented is about from the screenshots. So this is just a plain screenshot from our control page. You have on the left side the victims, and in the middle the active module, and on the right side a couple of modules, what you can do with the browsers that have been infected. For example, you can send him an arbitrary JavaScript command, you can get the remote page, you can get the cookies, you can set the page to anything the server wants, you can set the page location, you can set the page content, and here you can set the page location. The alpha indicates that it's not very well working so far, but we're always working on improving the system. Then we have kill victim's browser, for example, using some denial of service vulnerabilities in the browsers. You can also crash their browser if you want to. And finally, you can get the key presses. All right, so this is just a very, very simple web application we wrote for demonstration purposes. It is actually vulnerable to all kinds of vulnerabilities. You have cross-site scripting, you have SQL injection, you have file inclusion, file uploads, everything you want to. I'm just using this application to show you how the proposed system works. It's actually a gambling site, so you can play roulette or whatever you want on this page online. It's not online. We wouldn't put such a vulnerable system online. It just ran on a different server, internal server. Okay, so into this application we inserted a small JavaScript, namely the one that loads the JavaScript Trojan. It's as simple as putting the script tag there. In this case, we just assume we found a permanent cross-site scripting vulnerability. If you only have a dynamic or non-permanent cross-site scripting vulnerability, you need your victims to press on a link, for example. Okay, now the victim visited the page and becomes effective, which is shown as such an entry to the victims list. You know what kind of browser you have, and in this case we're just sending the client manual message, namely alert you have been owned. You just press the execute button and the victim gets the message that he has been owned. You can also get the cookies as shown here. Down there you can see the cookies. You can get the screenshot. This is what I call remote shoulder surfing. Just press get page snapshot or permanently get page snapshot, and you can always see what pages the victim is surfing on and follow him around anywhere. Okay, it also works with two clients, for example. You just have two entries in this area here, and as you can see, we were on a different page before. Whenever the victim changes the page changes to in our control page of the cross-site scripting Trojan. Okay, now you can also log into this portal using a username and a password and submit it, which is great because this can demonstrate our get key press functionality. In this example, I used Control Paste, Control V before it was even locked, but you see the username I used was Gek and the password was passwd exclamation mark. Okay, now even though the client logged in, we're still active with our get page snapshot, and now we as attacker are logged in too and see everything the user sees, logged in as the user that has been infected. Now we have an external link just to demonstrate you that the system is able to work across domains, which points to www.seconsult.com, and the URL stays the same, but it is loaded the page that the external page that the client went to, and still you can get the screenshot. Okay, and you can also point the server, the client, to another page location, for example, Deepsec. Yes, it says alpha for a reason there. And you can send arbitrary content to the client. Well, that's it from my side. Just in time, as I see. Any questions?
Does it work if the screensaver is enabled?
Excuse me?
Does it work if the screensaver is enabled?
If the screensaver is enabled, well, actually the screensaver doesn't have any impact on the page. So it's just a matter of the browser. Whenever the user manually enters another URL, the malware becomes ineffective. because the new page is loaded. But the screensaver doesn't have an impact on the Trojan itself. Yep.
Have you considered implementing something like a proxy server that gets you a view of the intranet from outside?
Not yet. Not yet.
Really,
That's true. The problem with getting the intranet is that you have to, in some way, brute force the IP address of the intranet, because you don't know. Or another way would be there's a vulnerability where you can get the history by brute forcing the links, just showing a huge list of links and checking what color the link is. And if the link was already visited, it is another color. That would be, for example, a way. Yeah, actually, it's a good idea. Right? Anyone? Well, thanks everyone for listening.